Hi, everybody. My name is Shreya. I'm really excited to be here. So the last talk ended with companies employing guardrails. The name of my company is Guardrails. So we'll talk about all of the different ways that we can do risk mitigation. But a big focus of the talk will be specifically on simulation testing. So this is going to be, more of a technical talk, maybe than some of the previous ones that you've had, and I hope I don't lose a lot of the, VC audience. So stick with this, and hopefully you'll see a lot of patterns about, what we can learn from self-driving and how it applies to generative AI and agents. Awesome. Before we get started, a little bit about us. The focus and the mission of the company really is AI reliability. So we are probably best known for our guardrails framework, which is very well used in open source, the largest collection of guardrails that you will find anywhere. But even with all of the guardrails in the world, a big problem that we ran into is it's very hard for static data sets of any kind to keep up with Gen AI, right? Machine learning AI isn't a new problem. But the modality of AI that we see today in practice is actually very different from your data science systems or your structured data systems, right? And a lot of this problem comes from just how infinite and unbounded Gen AI feels, or like text or image or video feels. So that even if you're creating any data set of any kind, typically there's so much variety and long tail edge cases, corner cases in the text modality that it becomes very hard for you to get coverage and sufficient representation over what you'll see in the real world, right? And this long tail problem is what ends up being pretty challenging, which is why you often run into people talking about, oh, we tested our system extensively, but when we went out into production, it failed in this unexpected way. Maybe, hallucinations in specialized knowledge, unexpected behavior when it comes to like multi-turn conversations, et cetera. Interestingly, this is, while it might feel like a net new problem with most consumer AI, this isn't a net new problem in AI generally. Specifically in self-driving cars, which is where a lot of my background is in, we saw this problem constantly because if you think about it, the real world is a long-tail distribution, right? You drive like many miles on the street, and yet you'll maybe find some weird way in which pedestrians are configured, which will make like driving on the real world challenging. And in self-driving cars, which try to automate driving, we saw this constantly, where even with the many millions of miles driven, it was very easy to come across like rare but high-risk scenarios that would all be different from each other, but different in a new way, and different like pretty commonly. So we had a huge 10-year head start compared to Gen AI in self-driving, and we had some of the best and brightest minds and a near infinite budget. So how we solved this problem in self-driving was by building a very high fidelity simulation engine that allows you to systematically and programmatically anticipate how your car will fail or how your car will behave across like a huge set of rare edge casey, corner casey scenarios, right? So rather than needing to drive your Waymos like a billion miles, you can actually just drive it for maybe on the order of millions of miles, but simulate it on the order of billions of miles so that you can figure out like how does it do when somebody's coming at your Waymo from within the blind spot? Does it still fail and behave gracefully? So what we're doing is building a product called Snow Globe that allows you to build the same category of simulation environments for your AI systems or your AI agents so that you can anticipate how they will behave before you actually put them out into production. We do this via large-scale simulation testing that generates realistic, diverse scenarios that can allow you to test out how your system behaves on hallucinations, off-topic responses, policy violations, et cetera. And because we're doing this in an automated way, you don't have to be limited by human creativity, right? Like often, if you're building anything to do with AI, it's some unfortunate person's job to be the person that's manually writing like scenarios and test cases, et cetera. And it's often limited by what they can anticipate, only by the failures that they've seen before. But if you can actually do this at scale with reasoning models, you can go beyond those constraints. Awesome. So I wanted to show you guys what simulation looks like in real life, or how we've built Snow Globe. So I'm going to present like a small video. So I'm going to simulate here. Whoops, sorry about that. What I'm going to All right, yeah. So what I'm going to show is basically simulating users interacting with this life coach GPT. So I make sure that I have a live connection to my life coach GPT solution and a short description about what my AI agent is. So in this case, this is a small system that can answer questions about life and work. And I can simulate lots of different types of users coming in and interacting with the system. In this small demo, I'm going to showcase specifically general users that just ask questions about life and work. So these are not malicious users, not somebody that's trying to jailbreak your system, but just a normal user that's coming in and doing this. So very quickly, we end up generating these synthetic user personas. So we looked at user personas that can essentially simulate what their talking style, et cetera, is, and we start to see a lot of these conversations come up. So we start seeing some synthetic user messages that are generated and are interacting with your system. But when we actually go through the entire process of simulation, we actually get this huge data set that looks very realistic and very diverse. So I'm scrolling through some of these synthetic conversations here, where you can actually programmatically generate different kinds of human behavior interacting with the AI agent that you've built, which you can use for either fine-tuning or optimizing your system by getting a lot of synthetic data that looks very realistic. You can use it for extensive QA, or you can use it for AI evals. Awesome, that's my time. So if you want to learn more about what simulations are, how they do, and just general learnings about how we solved a lot of these long tail challenges in self-driving cars, you can get in touch with me either at my LinkedIn, I've attached a QR code, or by contacting us at Snow Globe. Thank you.